Hello everyone, welcome back to a new session. You have seen how the image formation is taking place using a convex and concave lens with different positions of object. As the position of the object changes, we have seen the position of the image, nature of the image goes on changing. Now, how can we calculate or how can we locate the position of the image or the image distance? How can we calculate the object distance, or how can we calculate the focal length of a given lens? This is done using a simple mathematical formula known as lens formula. So let's study about lens formula and its applications in this session. Now let us consider the case of convex lens. See, a convex lens, optical center, principal axis, f and 2f on either side of the lens, equidistant from the optical center. An object is kept beyond 2f, a ray of light travelling parallel to principal axis. After refraction, it definitely passes through the principal focus. A ray of light again, second ray of light travelling through the optical center passes undeviated, and the point of intersection here, that is the place where the image is formed. Okay, and we get real inverted diminished image A dash B dash between f and 2f. Okay, now how can we measure the distance of image? The distance of the image from the optical center, it is denoted by a letter small v. So this is the distance of image, and the distance of object is again from the optical center, that is denoted by a letter small u. This is the object distance. Okay, distance of object from the lens, distance of image from the lens, it is denoted by a small letter v and it is denoted by a small letter u. Okay, now the focal length, distance of the linear distance between optical center and the principal focus is known as focal length. So this is focal length denoted by a small letter f. Okay, so this is the focal length. Now how can you calculate this distance? All these distances such as image distance, object distance and focal length related to a convex lens, it is calculated using a formula, simple formula known as lens formula. This formula is very important. A 100% sure question, numerical, can be asked in the board examination. So all of you pay attention, understand the formula, its applications. Okay, so lens formula is a simple mathematical formula which gives the relationship between object distance u. So I can write object distance is taken as u small u, image distance is taken as small v, and the focal length is taken as small f. So the lens formula is a formula, mathematical formula, which gives the relationship between object distance u, image distance small v and focal length f, and it is expressed as 1 by v minus 1 by u is equal to 1 by f. Okay, what is lens formula? Lens formula is given by the expression 1 by v minus 1 by u is equal to 1 by f. All of you must remember this formula. Its derivation is there, very simple derivation is there. This derivation is beyond the scope of the syllabus, so I am not going to derive it, but you have to remember this lens formula, 1 by v minus 1 by u is equal to 1 by f. Okay, this is lens formula. Now all of you learn this lens formula now itself. What is lens formula? 1 by v minus 1 by u is equal to 1 by f, where f is the focal length, u is the object distance, v is the image distance from the optical center of the lens or from the lens. Okay, now before we learn how to apply lens formula in our daily life situation or solving numericals, we must know what is Cartesian sign convention. All the distances related to a lens measured in terms of Cartesian sign convention. When we measure the distances related to a lens, remember that Cartesian convention is used. What is Cartesian convention? Cartesian sign convention. Cartesian sign convention. What is Cartesian sign convention? It is very simple. If you remember certain rules of Cartesian sign convention, all of you can solve the numericals related to a lens using lens formula very comfortably, very easily. So what is Cartesian sign convention? These are the conventions of sign. So very simple, Cartesian sign convention. All the first point, all the distances are measured, all the distances are measured from optical center of the lens. Okay, so all the distances are measured from the optical center of the lens. So imagine this is the optical center of the lens. Clear? Second rule, all the distances to the right of origin, is positive, is taken as positive. All the distances to the left of origin is negative. Okay, and all the distances, next, all the distances above principal axis is positive, and all the distances below principal axis is negative, Second rule. Okay, first rule, all the distances are measured from the optical center, all the distances to the right of the origin is positive, all the distances to the left of the origin is negative, all the distances above the principal axis is positive, all the distances below the principal axis is negative. Third rule, we have to remember the third rule. Focal length of a convex lens is always positive, and focal length of a concave lens is always negative. Okay, so these are the three rules you must remember to solve lens formula as sign convention, Cartesian sign convention. Now let us try to understand what is Cartesian sign convention. Very simple. Let us, in order to understand Cartesian sign convention, all of you must have studied Cartesian coordinate geometry in class 9 and 10. Basically, it is the same. So let us consider the Cartesian sign convention. Let us consider, see, a coordinate system. Let us make a coordinate system such that the optical center remains O remains the origin of the Cartesian coordinate system. This is x-axis, this is y-axis. Okay, x, y. Clear? Now I am keeping a lens such that the optical center of the lens coincide with the origin of the coordinate system. Very simple. See, first rule, all the distances are measured from the optical center. Remember, all the distances are measured from this optical center, that is the origin of Cartesian coordinate system. Clear? It is measured from the origin. All the distances are measured from the origin of Cartesian coordinate system, that is the optical center of the lens. Okay, this rule is clear to you? Very simple. Now all the distances to the right of the origin, see, all the distances to the right of the origin, towards right side, all the distances towards the right side is positive. Okay, and all the distances to the left side, all the distances to the left side is negative. All the distances to the left of the lens is taken as negative. You can see from optical center to the left side. Clear? So it can be expressed, this rule can be expressed in terms of direction of incident light ray. Okay, very simple it is. That is, all the directions, all the distances measured in the direction of incident light. This is the incident light rays. You can see incident ray. Okay, so all the distances in the direction of incident ray is taken as positive. Okay, clear? Are you getting it? Okay. Now all the distances opposite to the direction of incident light is negative. See, all the distances opposite to the direction of incident light, it is opposite to the incident light is negative. Clear? So same rule can be expressed in terms of direction of incident light. Don't get confused. Very simple. All the distances to the right of the origin is positive, to the left of the origin is negative. Okay. Now all the distances above the principal axis, see, above the principal axis, I mean the size of the object. See, you can see all the distances above the principal axis is positive. All the distances now below the principal axis is negative. Okay, so all the distances above the principal axis is positive. For example, you want to measure the height of the image, the height of the object AB, that is positive, and you want to measure the height of image A dash B dash, that will be negative. Okay, clear? And the focal length of a convex lens is always positive. You see, the focal length. What is focal length? The linear distance between optical center and principal focus. This is known as focal length. So the focal length is measured from optical center to the right. So the focal length of a convex lens is always positive. Now the focal length of a concave lens. So take the case of a concave lens. So which is the focal length? You can see this is the focal length, F. Okay, and in case of a concave lens, from the optical center to the object, that is object distance U, and the image distance, this is the image distance. You can see the image here, let me mark it as V, small v, from the optical center. So the focal length of a concave lens is negative. How the focal length is negative here? See, the from the optical center to the left of the lens, to the left of the lens, that is focal length. So the focal length will be always negative. So is it clear? If you remember these three rules, any problem related to a lens formula can be easily solved. Okay, so this is all about Cartesian sign conventions. And lens formula, remember lens formula, 1 by V minus 1 by U is equal to 1 by F. All of you remember this important magical formula, lens formula. It's not a lens maker's formula. Lens maker's formula is something different. You will learn in higher classes. Okay, this is lens formula which connects or which gives the relationship between focal length, object distance and image distance. Okay, so while solving lens formula, while using lens formula, you must apply Cartesian sign conventions to solve the numericals related to lens formula. Okay, now consider the case of convex lens. Okay, now let us consider the case of convex lens. Okay, I am writing here convex lens. So U is always standing left of the lens, so U is always negative. Okay, I mean the object distance. For image distance V, you know, in case of a convex lens, real inverted images are formed just behind the lens, and the last case when the object was lying between optical center and principal focus, you remember the case of a magnifying glass, we are getting virtual magnified image on the same side of the lens, on the same side of the object. In that case, the image will be somewhat here, right? So image distance will be negative. So or except all these cases, the image distances are taken as positive. So remember, in case of convex lens, image distance can be positive or negative. Image distance can be positive or negative. Focal length is always positive for a convex lens. So if you remember these 3 points, you can easily apply in the numericals to solve the problems. Okay, so for a convex lens, U is negative, V is positive or negative, and F is always positive. Now let us see the case of a concave lens. So in case of a concave lens, what will be the sign for object distance? U will be always negative, standing to the left of the lens. Clear? U is always taken as negative. And what about image distance? Image is always virtually erect and diminished. Virtually erect and diminished to the left side of the lens. So V is always negative. And what about the focal length? Focal length is also, you can see, to the left of the lens or against the direction of the incident light ray, it is negative. Okay. So for a concave lens, remember U, V, F all have it is negative. Okay, so for concave, U, V and F is negative, and for convex lens, U is negative, V can be positive or negative, F is always positive. So these points are very, very important. You just keep it in mind and understand the sign convention. Okay, so sign conventions are very important to solve numerical related to lens formula. You got it now? All the points are clear to you? Will you forget? This topic is very important. Again, I remind you, 100% question can be asked related to this topic. Okay, we studied about lens formula and Cartesian sign conventions, and it's important to know how to apply this Cartesian sign convention in lens formula to solve the numericals. Since applications are important, let's solve some applications. Let us see how Cartesian sign convention is applied in lens formula to solve lens related numericals. Okay, let's solve. An object is placed at a distance of 24 centimeter in front of a convex lens of focal length 8 centimeter. Find the position of the image. Okay, an object is placed in front of a convex lens. Object distance is U. What is the letter? Small u is equal to 24. Object distance in place of a convex lens of focal length 8 centimeter. Okay, you have to calculate the position of the image. V you have to calculate. Okay, so apply the Cartesian sign convention here itself. U, image object distance is taken as negative. Focal length of a convex lens is always positive. V, we have to calculate it. Okay, now let us try to visualize this case numerical for your better understanding and clarity. I will draw a convex lens. Okay, optical center F and 2F on either side of the lens. Okay, and I am placing an object AB at a distance. What is the distance given? It is U. Okay, at a distance U is equal to 24 centimeter. Okay, so now a ray of light traveling parallel to principal axis after refraction travels to the principal focus. A ray of light traveling through optical center passes undeviated the point of intersection where the image is formed, A dash B dash. You have to calculate this image distance. We don't know, you have to calculate it. U, object distance is always taken as negative to the left of the lens. Is it clear? And the focal length. So focal length is a linear distance between optical center and focus. So this is the focal length. So focal length is measured from the optical center to the right of the lens. It is taken as positive. For a convex lens, focal length is always positive. Now let us try to apply in the lens formula. What is lens formula? Lens formula is given by 1 by V minus 1 by U is equal to 1 by F. So what we require? We need V, the image distance. Therefore 1 by V, keep it here. I is equal to 1 by F. Taking to this side, it becomes positive, 1 by U. Okay. Now substitute the value with the proper sign. Apply the sign convention. 1 by V is equal to 1 by F. What is the value of F? Plus 8. Plus 8 plus what is the value of U? Minus 24. Minus 24. Now taking the LCM we can solve it. 1 by V is equal to, what is the LCM? 24. Okay, 24. That is how much here? 3 8s are 24. 3 minus 1. That's equal to 2 by 24. That's equal to 1 by 12. 1 by 12. So we are getting 1 by V is equal to 1 by 12. Therefore, V is equal to reciprocal of this, that is 12 centimeter. Okay. So V is equal to 12 centimeter plus, see the sign comes there automatically, plus sign comes there. So V is equal to 12 centimeter. Where is the image? Image is formed how much? 12 centimeter. 12 centimeter behind the lens. This is the behind portion of the lens, behind the lens. This is the front portion of the lens where the object is placed. Remember, this is the front portion of the lens, this is the behind portion of the lens. So image is formed 12 centimeter behind the lens. Clear? How the sign convention is applied? Very simple. Once you understand the concept and remember sign convention and the shortcut techniques, you can easily solve this kind of numericals.